So this is question number 27 from 2022 paper. So we have a and b be positive real numbers such that a is less than b, and we have the value of this particular integral is given. So to find the value of limit n tends to infinity 0 to n of this particular integral, to find the value of this. So we can write it as in the two parts. So suppose I1, that I1 is equal to 0 to n 1 by t square e to the power minus at square dt, and I2 is minus integral 0 to n 1 by t square to the power minus bt square dt. So let's first solve for I1. So if we do the integral over here, so it will be e to the power minus at square minus of 1 by t 0 to n, integral of 0 to n, so integral of 0 to n to the power minus at square. Okay, if we do the derivative, so it will be minus 2at, and integral of it will be minus 1 by t dt, right? So we can rewrite this equation in this way. Let it be in this way. To the power minus at square by t 0 to n there is a minus over there, so you can more. So here it is the minus, so we can write this equation to a 0 to n e to the power minus a t square dt, right? So when limit n tends to infinity, so we can also this at square, so in the next line we can write it this way. So as the limit n tends to infinity, I1 is equal to, so minus of e to the power at square by t 0 to n, and we can write it in this way, so 2a, so we can write at as 0 to n e to the power minus root at square. Okay, and if we put a t of root at, so here we will just put another root over a, right? So we can write it in this way, with at square. So similarly, so after simplifying it, we will find that, so this way, so minus of e to the power minus at square by t 0 to n, and after simplifying everything, so you will find that, so here this, if you consider this root a t is equal to t, so it will be minus capital T square, right? So here it will be capital T and here it will be capital T. So the value of it is given as, yes, the value of the integral is root pi by 2. Okay, so we will put this value root of pi by 2. Okay, so after simplifying you will find that here it will come as root pi root a. Okay, so this is for I1, limit n tends to infinity. Similarly for I2, so if we write for I2, so limit n tends to infinity, if we solve for I2, so it will be minus e to the power minus bt square by t 0 to n, right, minus root of pi root b. So to find the I1 minus I2, limit n tends to infinity, I1 minus I2. So if we find this I1 minus I2, so we will see that, so we can write it in this way, minus of so it will be plus, you can put it, so the little bit minus bt square minus of e to the power at square by t 0 to n plus root over pi root over b root pi root over a, and we have the limit n tends to infinity, right? So if we put the limit n tends to infinity, so now, so this will be 0 to infinity, right? So we can also replace this with 0 to infinity. So if we put infinity over here, so it will be 0. Okay, so it will become 0. So e to the power infinity is 1, so 1 by infinity is 0, so we have the 0 over here, and if we put 0 in place of t, so it will come in the form of 0 by 0. So here we will use the L'Hospital rule. Okay, so what it will be, so we can write it in this way, 0 minus, if we write this limit t tends to 0, so do the derivative e to the power bt square minus 2bt minus of e to the power minus at square minus 2at, and derivative of t will be 1, right, plus we can just take a common pi root over pi, so root over b minus root over a. So from here you can see that clearly that this is, it will be 0, so e to the power 1, okay, it was 0 1, so it will become 0, 0 minus 0, so ultimately the, okay, so this is the L'Hospital rule we have applied over here, since this 0 by 0 form is there. Okay, so the answer is root pi common root b minus root a. So let's check with the option. So the option in this case is D. D is the correct option. So for the question number 28, it is minus x is within this range, minus 1 to plus 1. Fx is the sum of this convergent power series. So this we can, if x is equal to x plus x squared by 2 square plus x cubed by 3 square, and we have this given x is to the power n by n square, right? So this is the given. So first we will do the derivative. So we have to find the value of f half. So the derivative is f prime x, so it will be 1 plus x by 2 plus x square by 3. This will like this. Okay, so x to the power n minus 1 by n. So from here, so multiply both sides by x, so it will be x of f prime x, so it will be x plus x square by 2 x cubed by 3. Okay, so it is nothing but, so we can write it over here as this is nothing but the minus of ln 1 minus x, right? So after simplifying, we can write this f of prime x is equal to minus of ln 1 minus x by x, right? So if we do the integral over here, so it will be f of x minus integral ln 1 minus x by x dx. Okay, we can also write the limit, so we can also write it in this form. So minus of 0 to x ln of 1 minus t by t dt. So this is for fx, right? So for f half, it will be minus of 0 to half ln 1 minus t by t dt. So this will be the option. This will be the correct answer for f half. So let's check with the option. So here the option is B, minus 0 to half ln 1 minus t by t. So B will be the correct option.